Okay, number 14 in your book. And it says, well, let's write the differential equation. So 4y double prime equals y. And the directions say substitute. So substitute y equals e to the rx into the given differential equation. So we're just going to plug it right back in to determine all values of the constant r. Okay, so here r is a constant, right? Other known as just a number. It's not a variable. For which y equals r is a solution, okay, to the differential equation. So to find r here, let's just substitute our e to the rx. So 4 times e to the rx double prime equals e to the rx. And so again, we're just taking derivatives. So the derivative of e to excuse me, e to the rx. Well, let's again rewrite this. E to the rx. I'm going to take the derivative, and then after the first derivative, I'm going to take the derivative again. And then there's no derivative on this side. So if we continue, 4, and again the derivative of this guy is e to the rx, right? So the derivative of, well, okay, let me write something down before I keep going. Let me write this in red or blue. Okay, so on the side, the derivative of e to the x, that's an x, is e to the x. Okay, by definition. The derivative of e to the, sometimes they say, call it kx, or in this case, rx. The derivative is e to the kx times the derivative of kx. Okay, so in other words, the derivative of kx, x is the variable, this is just going to be k e to the kx. And this will be very important when we start talking about growth and decay models. Okay, so let's continue the differentiation process. So e to the rx times, I'm going to write rx prime. And let me just switch here. Okay, so we have 4e to the rx times the derivative of this guy, right? If r is 2x, then the derivative of 2x is 2. So in this case, it's just r. So we have 4re to the rx equals e to the rx. And the goal is to solve for r. This is a very good review of just solving algebraic equations. This one has obviously an exponential equation. Again, very important equation that we'll be using. And I'm going to, I'm going to subtract e to the rx from both sides because I want 0 at the right hand, on the right hand side of my equation. What I want you to think about is think of quadratic equations. Usually when you want to factor something out, the general form is having a 0 on either the right or left hand side. So the reason I did that is because I have e to the rx and e to the rx. So I can factor e to the rx, right? That's my GCF, right? My greatest common factor or divisor. And what am I left with? I'm left with 4r minus 1 equals 0. So using the zero factor property, right? This is a property in college algebra you've seen. It basically says if a times b is 0, then a is 0 or b is 0, right? Or both of them are 0. So in this case, right, this is like my a, right, and this is like my b. So I have e to the rx is equal to 0, or 4 minus 1 is equal to 0. So if we solve this easy linear equation, r is a fourth. So we found our value of r. And then this equation, e to the rx equals 0. I mean, you can think of e to the 2x or e to the 3x is equal to 0. There's two ways you can try to find the solution, if there is any. So if you remember graphing e to the rx or e to the kx, again, it's an exponential function, and it either grows, right, or it decays. And the x-axis, right, that's a horizontal asymptote, meaning this value will, well, it's going to decrease, but this line will never touch 0. This will never touch 0. So it's saying, when is this function, where does this function intersect this line, or this function intersect this line? Well, they're never going to intersect because there's an asymptote there. Or another way of thinking about it is, if you try to take the ln of both sides from just college algebra, these are inverses, so it's just 1. And then the natural log of 0, well, the natural log of 0, if you punch that in your calculator, you're going to get an error, or you're going to get DNE, which is, it doesn't exist, because if you draw the log function, ln of x, when is this function going to be 0? So if x is 0, let me get the pointer, if x is 0, what's my y value? Well, this is never going to reach this, and this guy, right, will get closer and closer to this line, but it will never intersect that line. So your only solution is 1/4.